Exponentials are based on a number x to some power, and the power is some positive integer. So x to the n is x times x times x times x again and again until we get to the n x's multiplied by each other. X to the 0 is 1, x to the minus 1 is 1 over x, and x to the m over n is the nth root of x to the m, and it's also equal to the nth root of x all to the power m. Now, if n, it's important to note that if n is even, then x is greater than or equal to 0. And this gives us our exponent law. We can take these and we get the following, that x to the a times x to the b equals x to the a plus b. X to the a over x to the b equals x to the a minus b. X to the a all to the b is x to the a times b. X to the a, or xy to the a is x to the a y to the a. And x over y a is x to the a over y to the a. And this should be x greater than or equal to 0, and y strictly greater than 0. Note that a is an integer, if a is an integer, then the only constraint is you cannot divide by 0. When working with exponents, there are many ways we can simplify them, but I like to use this method. Convert all our roots signs to fractions, expand and collect common terms. Then we simplify the common terms, all in the numerator and denominator. Then we simplify each common term using log 2. Then we express our solution with positive fractions of each term, either in the denominator or the numerator. And we reintroduce the nth root sign. So let's take a look at this example. We're going to assume that x and y are greater than 0, and we're going to simplify this expression. So the first thing that I'm going to do is I'm going to take 3x minus 2 y to the 3 x to the 1 over yx squared root x. And I'm going to get rid of all the root signs. So here it's not so bad. X 3 to the minus 2, y to the 3, x to the 1 over yx squared x to the 1/2. Then what I'm going to do is I'm going to collect all my numbers first. So 3 over 1. Then I'm going to collect all my powers of x. So x minus 2, x to the 1 over, and here we need to expand this a little bit. This is going to be x squared x to the 1/2 times, and now I'm going to do my y terms. Y cubed over y squared. Remember, this is x squared squared. Now I'm going to simplify all these terms. So this is going to be 3 over 1. This is going to be x minus 2 or x minus 1 over, and here what I'm going to do is I'm going to do x to the 4 times x to the 1/2. I'm going to simplify this expression first, and I'm going to take an intermediate step. And this is going to be y to the 3 over y squared. And now I get 3 over 1 times x to the minus 1 over x to the 8 over 2 plus 1 over 2 times y to the 3 over 2. Bringing this up, we'll finish it. We get 3 over 1 times x to the minus 1 over x to the 9 over 2 times, and this should be y to the 2, times y to the 3 over y to the 2. From here, I'm going to bring them all into positive terms. This is going to be 3 over 1. And now the negative brings it to the bottom. So it's 1 over x to the 9 over 2 times x times y to the 3 minus 2, which is going to equal 3 over 1 times 1 over x to the 11 over 2 times y to the 1. Gives me 3y over x to the 11 over 2. My last step is to take this 11 over 2 and rewrite it as 3y over the square root of x to the 11th. And I am completed. As a suggested exercise, I highly encourage you to work through the following reductions. And in order to reduce these, we have to learn to factor. When factoring, there are three typical things we do. First, we factor using some efficient technique. There's lots of techniques out there. We're going to review one technique. The next thing that we do is we'll often use the quadratic formula. And this will become more and more common, especially when we deal with complex numbers. Finally, what we'll do is we'll use difference of cubes or difference of squares. And as well as our sum of cubes. These three formulas are very, very useful. Now, the three formulas are really useful to factor, but they're used a lot more often when using a technique called rationalizing the numerator or rationalizing the denominator. Now, to give you some experience with using this difference of squares and difference of cubes, we're going to go through three examples. Now, in our first example, we have a classic difference of squares. X squared minus 9. Well, the square root of x is x, and the square root of 9 is 3. So this gives us x minus 3 and x plus 3. Now, in our second example, we have x cubed plus 8. Now here, this will be an example of our sum of cubes. And x cubed means that we have a cubed, or x is a, and 8 is 2 cubed. So b is going to be 2. So this gives us x plus 2, and now x squared minus 2x plus 2 squared, or x plus 2, x cubed, or x squared minus 2x plus 2. And finally, our third example, we have x cubed minus 64. Now here, it is a difference of cubes, but it doesn't quite feel like a difference of cubes because we have a power of 6. But remember, x to the 6 equals x squared cubed. So this gives here a equals x squared, and 4 cubed equals 64, so b equals 4. So this is going to be x squared minus 4, then x squared squared minus 4x squared, or plus 4x squared, because remember we're using this equation, plus 4 squared, which equals x squared minus 4 times x to the 4 plus 4x squared plus 16. Now we're not quite done because this here is a difference of squares. So we get x minus 2, x plus 2, x to the 4 plus 4x squared plus 16. Now that we've reviewed using our difference of squares, difference of cubes, and sum of cubes, we're going to review a technique used for factoring. Now we're going to review our factoring techniques. Now, when we factor, I like to use a technique called the MAC-AB system. Now, there are many different ways to factor, but I always use the MAC-AB. And the thing I like about the MAC-AB system is it always works. So given a quadratic a squared plus, or ax squared plus bx plus c, we're going to find integers e and d such that the product of a and c equals the product of d and e, and b equals d plus e. If no such integers exist, simply use the quadratic formula. Okay. Then we're going to rewrite the quadratic expression using the d and e we created. We're going to factor what we can out of the ax squared plus dx and ex squared plus c, always factoring out a minus sign if the leading term, a or e, is negative. And then we're going to factor out the common factor you have isolated, or we have isolated. So what is the technique here? Well, the first thing I'm going to do is I'm going to create a MAC-AB table. So multiply A and C. That's going to equal 1 times 2, which equals 2. And we're going to add to B, and that's 3. So we need to find two integers that multiply to 2 and add to 3. And if we take 1 and times 2 equals 2, and 1 plus 2 equals 3. So we're going to let D equal 1 and E equal 2. We do this, this expression is going to, x squared plus 3x plus 2 equals, we're going to rewrite this using D and E. So it's x squared plus 1x plus 2x plus 2. And now out of our first two terms here, we're going to factor out what we can. And there's an x in both terms, and that's it. And there's no minus sign, so it's just x. We're left with x plus 1 plus, and in our second terms, we can factor out a 2. 2 comes out of here, and we're left with x plus 1. Now what we're going to do is we're going to factor out this common root that we've created, x plus 1. And we're left with x plus 2, and we factor. What about our next example? Well, we repeat the same process. Multiply AC, which is minus 3 times 1, which equals minus 3. We're going to add to B, which is minus 2. So we need to multiply to minus 3 and add to minus 2. Minus 3 times 1 equals minus 3, and minus 3 plus 1 equals minus 2. So we're going to let D equal 1 and E equal minus 3. It doesn't matter the order. The order of these doesn't matter. You just pick 1 to be the first value and 1 to be the second value. So if we have minus 3x squared minus 3x plus 1x plus 1, that's what our expression equals. And now I'm going to factor to the first. So this equals minus 3x minus 1. Or minus 3x, sorry. X minus 1. And let me write that a little bit cleaner. Minus 3x, x minus 1, plus, and out of my second term, I get 1, x plus 1. And notice because there was a minus sign here, factored out the minus 3x. Here, this should be a plus, and we're going to get a common term, giving us x plus 1 minus 3x plus 1. And finally, we're going to do our last example. We are going to multiply AC, which is 1 times 4, to equal 4. We're going to add to B to equal 4. Well, 2 times 2 equals 4, and 2 plus 2 equals 4. Well, D equals 2 and E equals 2. So this is equal to x squared plus 2x plus 2x plus 4. Which equals, out of our first two terms, we can factor out an x, leaving x plus 2. And our second two terms, we factor out a 2, leaving x plus 2. Our common factors leaves us with x plus 2, x plus 2. This process, what I love is it always works. And the most challenging part is solving for these constants. Everything else is like clockwork. Factor out by your largest number out front of your x's, and always factor out the minus sign. And if you do that every single time, it will always work, as long as we can solve for this MAC-AB chart, for the coefficients D and E that satisfy our constraint.